All right, let's dive into something really interesting and honestly a little bit unsettling. We're going to talk about how the simple act of drawing a line, separating one thing from another, literally builds our entire world, from math all the way to physics. And what if that whole foundation is just, well, flawed? So let me just kick this off with a pretty bold question. Think way back to geometry class, right? Learning about points and lines. What if the very first thing you learned about all that was a lie? Or maybe not a lie, but a convenient fiction? Yeah, I mean, think about it. By definition, a mathematical point has no size. A line has no thickness. So if you could actually draw them perfectly, you would see, well, nothing. Absolutely nothing. To make them show up on a screen or on paper, we have to give them some width, some size. We have to cheat. And this little, totally innocent cheat, that's the key to this whole explainer. Okay, so that little cheat we just talked about, it actually has a name. And it turns out it's pretty much the most fundamental tool we have for making sense of the world. It's called making a distinction, and it's exactly what it sounds like. It's the simple act of saying, this thing here is not that thing there. It's how we carve up the entire universe into little manageable pieces so we can talk about them, study them, and, just survive in the world. And look, this is not some abstract philosophical game. This is core to our survival. I mean, we distinguish edible plants from poisonous ones, right? Friend from foe, our group from the world outside. Our entire social world, our digital world, it's all built on these distinctions. Man versus woman, this simple binary of 0 and 1 that runs all of our computers. This act of drawing lines, it is literally everywhere. So, okay, how does this basic, almost primal survival instinct end up building, well, everything? Let's take a look at how we've used this one simple tool to build our most complex and powerful systems of knowledge. You see, every single distinction we make has two sides to it. It's like a coin. Take the line drawn between man and woman. On the one hand, yeah, it can create helpful social structures like marriage and families. But that exact same line can also lead to conflict, inequality, and long struggles for emancipation. Every line we draw both creates something and divides something. And you know where this is more true than anywhere else? Mathematics. Math is the ultimate language of distinction. It's built on these 4 pillars, right? Definitions, axioms, theorems, and proofs. And every single one of them depends on being able to draw these perfectly clear, totally unambiguous lines between concepts. Our definitions and axioms, they're kind of like articles of faith. They're the starting distinctions we all just agree on so we can get started. But what if that foundation, this deep belief in perfect, clean distinctions, what if it has some really serious problems? What if the code we've used to write our reality has a few bugs in it? The source material we're looking at today points to 4, let's call them fundamental cracks that appear when we lean too hard on this idea of making distinctions. So let's break them down. Let's look at the 4 ways our most trusted tools for understanding the universe might actually be leading us astray. Okay, let's start with crack number 1. And it takes us right back to where we started, that simple line. We all have this intuitive feeling of what continuous means, right? A smooth, unbroken flow. But our mathematics, which is built entirely on separate numbers, actually really struggles to describe that. See, to describe a line using numbers, we have no choice but to break it apart into individual, separate points. We've got 0, we've got 1, a half, a quarter, even weird ones like the square root of 2 or pi. We are literally forced to chop up that smooth whole line into an infinite collection of separate little locations, just to describe it. And this leads to a fantastic analogy. The number line becomes a kind of Swiss cheese. Right? If you only use nice, neat whole numbers and fractions, your line is just riddled with holes. There are gaps all over the place. So what's the fix? Well, mathematicians are clever. They invent concepts like irrational numbers, and of course, the big one, infinity. The whole idea is that if you have an infinite number of points, you can finally plug all those holes and make the line complete. But what if infinity itself isn't real? What if it's just another one of those convenient fictions? And that brings us to crack number 2. The source has this incredible quote. It says that infinity and irrational numbers are more like gnomes and elves. Think about that. They can be really useful, but they don't really exist. They're just powerful characters in the story we tell ourselves with math, but you can't actually find them out there in the real world. All right, for crack number 3, let's jump out of pure math and into the real world, into science. The entire scientific method is built on this one core distinction. You have the objective observer over here and the environment being studied over there. But quantum physics comes along and just blows that all up. The deeper you look, that distinction completely dissolves. The very act of measuring something changes the thing you're measuring. There's no clean line between us and the universe we're trying to figure out. And here's where it gets kind of tricky. As the source says, nature can play a joke on us. It can let us make a distinction that doesn't actually exist in reality, so our measurements might just be confirming the lines we've already decided to draw, not revealing the true undivided nature of what's out there. We just end up seeing what our tools were designed to separate in the first place. This all leads us to the fourth and final crack, and this one is probably the most mind-bending of all. We just assume the world is made of tiny, distinct little balls called particles. But when we look really, really closely at the quantum level, reality starts to, well, protest. We get all this weirdness like quantum mechanics, a wild vacuum, dark matter. Now, what if these aren't just new things for us to find? What if they're actually signs from nature that it isn't made of little bits at all?
Okay, so if our entire world, built on all these little distinctions, is full of cracks, what's the alternative? This is where things get really interesting, because the source proposes a pretty radical new way of looking at everything.
It's a new conjecture. And the question is this: what if nature is just one single, continuous substance, with no built-in distinctions at all? What if it's all just one thing? A single fabric of reality, and things like you, me, and planets are just temporary shapes, like waves in an ocean. They're not truly separate objects, just patterns in the whole. Now, to even start talking about this idea, we'd need a completely new tool. So the source proposes this concept called the in-between. And you can think of it as a way to mathematically talk about a piece of a line, not as a collection of a bajillion little points, but as a single, indivisible whole. It's about capturing its flow instead of just its locations. But here's the thing, the in-between isn't some magic bullet that solves everything. It's really more of an admission. It's an act of intellectual humility. It's a way for us to formally build our own ignorance right into our math, a kind of placeholder for the continuity we feel but can't yet describe with the tools we have. And that really leaves us with one last, big, provocative thought to chew on. We started this whole thing with the simple act of drawing a line. We've seen how that one act builds our entire reality, but also how it might just be an illusion. So it forces us to ask, if nature itself doesn't draw lines, why do we? And what might we see if we could just learn to stop?